Hello everyone. In this video, we'll understand about estimation theory. This comes under statistical inference. In statistical inference, we have two types. One is estimation theory. The other one is hypothesis testing. So we have a separate playlist for hypothesis testing where we had done many problems related to different types of tests. Link of the same is given in the description below. So now let us move into estimation theory. It refers to the technique and methods by which population parameters are estimated from sample data. For example, I want to estimate what is the population mean. I will collect the sample. From the sample, random sample. From the sample, we will find out the average, which we call it as a sample mean, and that will become a estimate for the population mean, whatever we are looking for. So when one makes an estimate of a population parameter, a sample statistic is used. This sample statistics is called an estimator. Example, X bar, that is sample mean, is a point estimate of the population mean mu. Many different statistics can be used to estimate the same parameter. Means here I am trying to find out average. I can also use median, mode, depending upon the situation, whatever it is. Criteria for good estimator. A good estimator must possess the following properties. The first one is unbiasedness. Unbiasedness means, for example, suppose if I consider theta as the population parameter, then whatever we are estimating the sample estimate, and if I consider that as theta bar, means if theta is the population parameter and theta bar is the sample estimate, and if expectation of the theta bar, if it is theta only, then we say that the estimator, that is theta bar, possess the property of unbiasedness. When we talk about consistency, it means that if I keep on increasing the sample size, the estimate will almost be equal to your parameter. Efficiency. Efficiency means like whichever estimator has the least variance, then that particular estimator is considered to be having a better efficiency than the others. Sufficiency. A particular statistic is said to be a sufficient estimator if it contains all the information about the population parameter in the estimator itself. Further, if some estimator, if we say it is sufficient, then it should be consistent also. It should satisfy efficiency property also. Then you say it is the estimator is having a sufficiency property. So for any particular estimator to be good one, it should possess all these properties. Types of estimation. This was developed by Professor R.A. Fisher in 1930 and has grouped by him in two classes. One is called point estimation. Another one is interval estimation. Let us see what are those two. Point estimation. A point estimate is a specific value of a sample statistic that is used to estimate a population parameter. Means for that, what we do already we discussed. We draw a random sample from the population. Then we estimate the value of an unknown population parameter. For that, we typically consider n observations. N can be any size of the sample, basically sample size. So for example, X bar, that is sample mean, is considered to be the point estimate of the population mean mu. P cap, that is sample proportion, is a point estimate of the population proportion P. And S, capital S, that is sample standard deviation, is a point estimate of population standard deviation sigma. So this is about point estimation. Let us move on to the next. Interval estimation. An interval of scores that is established rather than arriving at one particular value as an estimator or estimate for a population. Here what we do is we try to find out a lower and upper limit, and then we say that the population parameter lies between these two values. So an interval of scores that is established within which a population parameter, that is theta, is likely to fall. When that parameter is estimated from the sample data, means that lower limit and upper limit are found from the sample data only. And this interval estimation establishes an interval consisting of a lower limit and an upper limit in which the true value of the population parameter is expected to fall. This interval is called confidence interval. Shortly, we say CI. In reference to inferential statistics, or in the parlance of inferential statistics. Meaning of confidence interval is that if you keep on taking repeated samples, the probability that the true value of theta will fall in this interval is a certain percentage. The common confidence percentages what are considered is the popular confidence percentages are 95%, 99%, and sometimes 98%, and also 90% also. So these are the standard confidence percentages, what is being considered. Means it is very similar, or you can say it is an opposite to your significance level, what we studied in hypothesis testing. Here, when we say 95% confidence, it indicates 5% level of significance. If we indicate 99% confidence, it indicates that it is 1% level of significance. Confidence interval, abbreviated as CI. A confidence interval is a particular kind of interval estimate of a population parameter. Means instead of estimating the parameter by a single value, which we do it in point estimation, here we find out an interval in which this population parameter is likely to fall in between those two values. Means you try to find out an interval having a lower limit and an upper limit, and you say that the population parameter falls in between these two limits. So these are used to indicate the reliability of an estimate. So if I try to increase the desired confidence level, means from 90%, let us say I want to increase it to 95%, then naturally the interval also will widen. Similarly, if I want to increase it from 95% to 99%, again, the interval will widen. So the increasing the desired confidence level will widen the confidence interval.